In this demo, we are going to use pipes and dplyr functions to clean up an imported data set. So in order to keep these videos short, I'm going to try not to go over things that we've already looked at in the video series. So the prerequisites for this one are just the read_CSV reading in data video and then the pipes video. So what I've done here is I have an R project set up in this folder. So if you just go to File, New Project, and then, well, I don't want to do that through here, but click Existing Directory, put the project in the folder where your data is, and then you'll see that R proj folder. The R session will be named after the project, and then we can read in these sensor files without telling R the directory they're in, because it'll automatically look here. So let's read in the data, and we're going to call it data. So data read_CSV, and we're going to use test sensor _2.csv, and this has a 2-line header at the top. And if we don't do skip equals 2, then it'll read in all funky. So, and I'll look at this real quick so you can see what I'm talking about. So if we don't skip these first 2 lines, then read_CSV will think this is the only column name and all this is the data in one column, which is not what we want. So if we do that, we see that our data looks like this. So there's a few things that we want to do here. One, we want to change these column names because they have special characters in them, which is going to make them difficult to reference as we're writing code. The other thing that we want to do is get rid of these columns back here because they're extra. We don't need them. They're just full of NAs. So we want to just kind of clean up. And then the last thing that we want to do is if we go to the bottom of this data set, if I can get this to allow me to scroll. Well, it's not allowing me to quickly go to the bottom, but there are a couple NAs at the bottom in temperature and intensity and date, and we're just going to get rid of those rows. So we're going to do this with pipes because it'll allow us to do it all basically in one statement, rather than doing a bunch of statements and saving data as in a bunch of different stages. So this will be faster and cleaner and easier to interpret. So remember, when we do a pipe, it's basically saying, do the thing to the left of the pipe, then take the result of that and put it into the first argument of the next function. So in that case, in our case, that next function we want to use is called rename, and that is going to rename those kind of weird or not great column names. And the way rename works is you give it the new name and then the old name in that format. So the new name equals old name, it'll rename those columns. So in this case, I want my date time column to be called date time, and then we need to give it the old name. And the old name is complex and difficult to type out. And so a shortcut I like to use is I'll say, if you type data and then the $, it gives you the columns that are in that data frame. And so if you type enter, it gives you it in the correct format with those backticks, and then you can delete the data in the front. And we can do this with multiple columns at the same time. So I'm going to say comma, and then I want the next one to be called tempf. And again, I can do that trick and grab tempf and then delete data, because I just want to give it the column names. I don't want to give it the name of the data frame or tibble. And then finally, intensity is going to be that. And I can go down and grab intensity. Okay, so you'll see now when I run this, these 3 names are going to change to those easier to remember names. Boom, good to go. So now the next thing that we want to do is we don't want all these other columns. So we want to keep these 3 columns. To do that, I'm going to use the function select. Select selects columns. And if you give select column names, it will pull those columns out. If you give it column names with minus signs in front of them, it will drop them. So let's do an example with the minus. We can say minus button down, which I have to use the ticks on because it didn't change that name. And if we do that, it'll drop button down. So if we look over here, we'll watch that disappear. Now button down is gone and only button up is there. So if we select columns, it will just pull out those columns. So if we do date time, temp F, and the intensity, and even though this is in the same statement, because we named them up here, that's what they're named when we do select. And if you did select by a standalone statement, you'd have to give it the name of the tibble or the data frame. But here, because we're piping in, we don't have to. So if we do that, now you see we just have those 3 columns, right? So there's one other good trick here. I'm going to read it in the original way, just so you can see all the different columns. You can also tell it to select a sequence of columns. So if the first column I want is date time, the last one is this intensity. And if I put a colon in between, this is telling select I want everything from date time to intensity. So if I run that, it does the same thing as the previous one. So if you have like 8 or 10 or 12 or however many column names, 100, you don't want to type them all out. So doing something like this could be really handy. Then the final thing that we want to do is we want to get rid of those NAs at the bottom. And so we can use a function called drop NA. And if you do drop NA with nothing in the parentheses, it's going to drop any row in your data that has an NA. So importantly, we don't want to do this before we select these, because all those other columns were just NAs. So if we do this, all we're going to see is a couple drop off. So we look, this is 29,058. Let's see what it changes to. 29,055. So it just dropped the last 3 rows that had NAs. Now, let's look at what happens if I comment out this line. So in this case, I'm going to do the same operation, right? But when I pipe to drop NA, we have these other columns that are full of NAs. So because it's going to drop any row with an NA in it, this is well, you can predict what's going to happen, and then let's look. Well, now we have nothing because every row had an NA, so it got rid of everything. If we do this, so now when it goes in to drop NA, it only has these 3 columns, right? So if we do that, we can look at these and we know that these are all, those NA columns are missing now. And so if we do drop NA, it's only going to do the few that are at the end. And so it just drops those 3. So now if we look at data, we have a nice clean data set, no NAs at the bottom. And that time it allowed me to scroll through a lot easier. So let's real quickly just look at what this looks like with the NAs. Go to data, go to the bottom, and you can see there's just these 3. And there's no reason to have these. This is just basically at the bottom of every file, there's a few from when you push the button to download the sensor. So we definitely don't need these. And so we can drop them with drop NA. And so now we have a nice, neatly formatted table with easy to remember column names that we can take into our plotting or analysis.